want to say some things about quantifying reactions when you are starting with masses. It's just as a reminder, when we are converting from a reactant to another reactant, like for example, to figure out how much of two things we need to have to react completely, we have to go from one species to another. We need to use the mole-to-mole ratios because these chemicals combine in whole molecules, or another way of looking at it is in whole mole ratios. The mole-to-mole ratios are in quantities that we're able to see. They're more on a macroscopic scale. When we're trying to calculate the amount of product formed by something, again, we're going from one chemical species to another. That also has to be in a mole-to-mole ratio. So when we have a limiting reagent problem where we have two reactants and we want to figure out how much of one product we have, when we go from one species to another, we have to use mole-to-mole ratios. But often we're going to be given a mass, something that we can weigh out on a scale. And we're going to also know the mass of what product we want. So for that, we have to do a couple conversions. So if we start with the mass, say, of copper chloride, and we want to know the mass of aluminum chloride that it can create, we have to go from mass of copper chloride to moles of copper chloride. Then from moles of copper chloride to moles of aluminum chloride, and then finally to mass of aluminum chloride. Now we know how to do this. We've done it step by step, but we haven't done it all in one problem. To go from mass to moles, we have to use molar mass. And in that direction, we're going to divide by the molar mass. To go from moles of copper chloride to moles of aluminum chloride, we have to use a mole-to-mole ratio. Then to go from moles of aluminum chloride to mass of aluminum chloride, we're going to use the molar mass of aluminum chloride. And I didn't say it, but this would be the mass of copper chloride, copper 2 chloride. Okay, so let's do an example. Let's say that we have 20.2 grams of copper 2 chloride. And let's assume that we have an excess of aluminum. So this is not a limiting reagent problem. We just know that we have copper 2 chloride. We have 20.2 grams of it, and we want to know what is the mass of aluminum chloride that we can get from it. So I'm going to essentially follow this algorithm. I'm going to start with what I have, which is the mass of 22 grams of copper 2 chloride. And I'm going to go to moles of copper 2 chloride. I've already calculated the molar masses of my species. So I'm going to use the molar mass of copper 2 chloride. That's the mass of copper plus twice the mass of chlorine. And that number is 134.45 grams of copper chloride per 1 mole of copper 2 chloride. So I've done that. So now I'm here. Actually, I've done this, and now I'm here. But now I want to get to moles of aluminum chloride. I'm doing this up here. So I need a mole-to-mole ratio. 3 moles of copper 2 chloride create 2 moles of aluminum chloride. So now I'm here. So I have gotten rid of that, gotten rid of moles of copper 2 chloride. I'm at moles of aluminum chloride. I'm going to use now the molar mass of aluminum chloride to get the mass. 1 mole of aluminum chloride is 133.3 grams of aluminum chloride. And when I calculate this all out, I get 13.4 grams of aluminum chloride. So just to review this, that's the molar mass of copper chloride. This is a stoichiometric ratio, or a mole to mole ratio. This is the molar mass of aluminum chloride. And this is our answer.